Go through number 6 through 12 in review packet number 2. It says find the exact degree equivalent of 5 radians. So all you have to do is convert degree to radians, or radians to degrees. So I'm going to do 5 over 1, make it look like a fraction, times 180 over pi, which makes 900 over pi degrees. So this might be something we want to add to our formulas for the final things, right? Converting from radians to degrees and degrees to radians. So converting from degrees to radians, right? We multiply the degree by pi over 180, and converting from radians to degrees, we multiply the radian by 180 over pi. All right, so something else to add to our formula. So that's what I did here. 5 over 1 times 180 over pi. You just leave it 900 over pi degrees. Now, if I ask for this to the nearest tenth, which I won't, then you would throw that in your calculator. But that's a perfect answer. Now, what is 200 degrees in radians? So we're going to go the other way. So we're going to do 200 over 1 times pi over 180. So that makes 200 pi over 180. I'm going to reduce the zeros, right? And they have 2 in common, right? So that reduces to be 10 pi over 9 rad. So that would be the answer for that one, and this would be the answer for 7. Okay, given the polar coordinate, 3 to 40, find the Cartesian form. All right, Cartesian means we're changing polar into xy, all right? And the way you do that, now think of trig, right? Isn't the x cosine and isn't the y sine? So you take, we're going to make our point here. We're going to do 3 cos 240 times 3, or comma 3 sine 240. So let's add that to our formula sheet. Converting polar coordinates to Cartesian. Okay. So how it works is it'll be r, the radius, comma, a degree. And what you're going to write is r cos the angle, r sine the angle. All right. And then what we're going to do is finish this up. So let me get some scrap here. All right. So we have to do 3 cos 240. Right? So that means if I graph 240 degrees, it'll pull me here. Right? This is the 180 line, which makes this 60. Makes this 30. Side across from 60 is radical 3 over 2. Side across from 30 is a half. We need cosine. That would be there. And in this quadrant, cosine's negative. So that's 3 times negative a half, right? So this point becomes negative 3 over 2. And now we're going to do the sine. What would 3 sine of 240 be? Well, we're going to use the same picture, right? Sine is the y value, but it'll be negative. So it's 3 times negative this guy. So we're going to put negative 3 radical 3 over 2. Here's number 8. All right, what is 5 negative 5 in polar? All right, now we're going to go the other way around. This is Cartesian, and we want to go to polar. So what I suggest, I'm going to go to my scrap paper again for number 9 here. We have the point 5, negative 5. I'm going to graph it. So over 5, 1, 2, 3, 4, 5, down 5, 1, 2, 3, 4, 5. 5, negative 5 would be here, so I'm going to draw a line, right? Now, polar is trig. So basically, I'm drawing a right triangle here. I know this is 5. I know this is negative 5. Now, these are both the same, guys. What kind of a triangle is it? It's isosceles. That means this has to be 45 and this has to be 45, right? If you didn't know that, you could have done, if I were to redraw it, this is theta, right? This is 5, this is negative 5. You could do tan theta equals opposite over adjacent. And you get tan theta equals negative 1, guys. And what angle makes tangent equal to 1? 45 degrees. So, guys, we know the angle's 45. So how big would this turn be now from the beginning? 315. So I know the angle here is going to be 315. Okay. Now, only thing left to do is to find out how long this is. That's the r. So we're going to do the Pythagorean theorem on that. So I'm going to do 5 squared plus negative 5 squared equals c squared. So 25 plus 25. That's 50. Take the square root, right? This would be 5 radical 2. And since it's a radius, it's a length, it's always positive. So 5 radical 2, comma, 315. All right. So to go, the key from converting to polar and back is to remember that r comma theta is this guy. To go backwards, you graph the point and then do trig. All right, number 10, a log equation. So I'm hoping here you guys remember that since these are the same base, and this is adding, these can be multiplied. So it becomes log x plus 3, 2x plus 3, x plus 5 equals 2. Now this becomes x plus 3 squared equals 2x plus 3, x plus 5, right? Now I'm going to distribute both sides. So if I distribute this, I'm going to get x squared plus 6x plus 9. Distribute all this, I'm going to get 2x squared plus 10 and 3 is 13x plus 15. All right, it's a quadratic, so I'm going to set it equal to 0. All right. And I apologize for stopping there. The puppy got into something. So I'm going to subtract x squared over 6x and 9 to here. So now I have 0 equals 1x squared plus 7x plus 6. And that factors into x plus 6, x plus 1. So we have two possible answers, negative 6 and negative 1. Now, you can't just circle those. Logs you have to check. You cannot have zeros as the base or as the number. And if you plug negative 6 in, we totally get a negative for in there, that location, so we're going to reject it. Negative 1 will work though. So I'm going to box that off. Okay, next one. Number 11. Now it's another trig equation, which I know you guys aren't huge fans of. Big thing with trig equations, you can never have a double angle formula here, or these have to match, so that's a problem. So this guy right here is the one I'm going to change. Now, anytime it's a square and you have to change it, you're going to use the Pythagorean identity. So think for a second, we know sine squared plus cos squared equals 1, right? Sine squared plus cos squared equals 1. We need to figure out what sine squared equals, so just subtract that over. So that means sine squared is going to equal 1 minus cos squared. So I'm going to bring down the 2, and where sine squared is, I'm going to replace it with 1 minus cos squared plus cos x equals 1. And now I'm going to distribute the 2. So I get 2 minus 2 cos squared theta, or x we're using here, sorry, plus cos x equals 1. Now I'm going to put this in the correct order. So it's negative 2 cos squared x plus cos plus 2 equals 1. Right now, I hate having negative quadratics. So I'm going to move all this to the other side. So I end up with 0 equals 2 cos squared x minus cos x, and 1 we subtract 2 over, you get negative 1. All right, now you guys have options. You have your calculators available to you, right? So you can either use quadratic formula. You can just factor this. It does factor. Everything on here is pretty factorable on your final. So that factors into that. And that, right? Now set each piece equal to 0. So this is cos x equals 1. This is cos x equals negative a half. All right, so let's do 1 first. You get 1, 0, or negative 1. You guys are thinking of the unit circle. Where on the unit circle is cosine equal to 1, right? And that's going to be at 0 degrees. Now, we have to, if you get 0 degrees, it means 360 is also possible. So look at the interval. If it's a solid bracket, you have to put 360. Soft bracket means no 360, right? And they want us to write this in radians. So I'm not going to write 0 degrees. I'm just going to write 0. So that's that part. Now, a half. What angle makes cosine equal a half? And that would be 60 degrees, right? So now, okay, notice that was negative a half. So I'm going to draw the 60 degrees in the quadrants where cosine is negative, there and there. So how far is it from here to here? That's 120. That's one of the answers. And how far is it from here to here? It's 180 plus 60, which is 240. All right, now we got to convert these into radians. So I'm going to do 120 degrees times pi over 180, which would be 12 pi over 18. They both have 6 in common, so that's 2 pi over 3. Now there's another way of doing that that's faster, right? See how that's 60 degrees? 60 degrees is pi over 3. 120 is 2 times 60. 60 times what makes 240? That would be 4 pi over 3. So those are the other 2 answers. So this one had 3 answers. 0, 2 pi over 3, and 4 pi over 3. All right, one more question. Given the equation p of x equals 2 to the x, explain how this graph looks different. All right, guys, now anytime you want to manipulate something, you always go from left to right, and we're going to talk about what everything means. All right, now, the negative out in front. Okay, puppy's up to no good. So, given this thing, okay, what I would do first here, actually, is distribute this negative 6. So I just realized it wasn't negative 6 times this, it was negative 6 with a parenthesis around it. So I'm actually going to distribute it first. I get negative 6 times 2x minus 5. Negative 6 times 10 makes plus 30. Okay, so you could distribute that first. Now, negative out in front means a reflection. So, reflection over x-axis. You can even do it in bullets if you want to. It's a reflection over the x-axis, but it's got to be in the correct order for the way this looks. So that's the first thing I hit. Then the 6, that's going to be a vertical stretch by a factor of 6. You can even number these 2 because they do have to go in order. 3. The next thing we come across is this guy, right? That's a shift 5 units to the right, horizontal shift 5 units to the right. Right? And finally, that's 4 vertical shift up 30. So this would be this guy. Now, if you left it like this, if you left it in parentheses, you actually have to go from the inside out. So if you didn't distribute this, right, so there's actually two answers. If you distribute it, which I think is easier, that's the easier thing to say. If you left it like this, you'd have to go from the inside out, basically, and say the first thing you would see is inside the parentheses. So you would say shift 5 to the right. Then you would say, let's say, down 5. Okay. Then, right, you would do inside the parenthesis first. Then you would say reflection over the x-axis. Then you would do the multiplication. Reflection over x-axis. And 4 vertical stretch by 6. So if you distribute it, you could just go from left to right. Makes it simple. If you leave it like this, you actually have to do PEMDAS in the parentheses first, and then go. So there's 2 correct answers. All right, guys. A lot of the stuff on this page you hadn't seen in a long time, which is why I kind of didn't have you do an assignment on it. But the last couple of pages here, right, I want you guys to try on your own, and we'll see how it goes. So the next assignment, we'll have a Google form due Friday of you guys finishing all of this.